Today is the last day of Chapter 7, and we are solving radical equations and inequalities. So what this means is we're going to be having equations that have square roots in them, or cube roots, or whatever it may be. We're going to have to solve those for x. So we're going to just talk about a few different scenarios where we can use radicals to solve equations. So the first couple of definitions we need is a radical equation is an equation that contains a radical. And extraneous solutions, this is something that we've touched upon before, but extraneous solutions are a number that does not satisfy the original equation. So you want to make sure that you test all of your solutions to make sure they're going to satisfy and go along with the initial problem. So all of these is going to be very crucial that you go back and check your work. Alright, so let's go ahead and try one, or a couple. So what we're doing here, these are almost just like variables. You want to get radicals on the side by themselves. So I'm going to subtract the 2 and leave myself with the square root of x plus 1 is equal to 2. Once you have this by itself, you get rid of this by squaring both sides. So I can square this and square this. So I end up with just x plus 1 is equal to 4, x is equal to 3. If I go back and check that, the square root of 3 plus 1 plus 2 is the square root of 4, which is 2 plus 2, which does indeed equal 4. So the goal here is to try to get these on a side by themselves. For this one, so when we look at this next one, notice we have square roots on both sides of this. So when we have the square roots on both sides, you have a couple of options. I could put them on both on one side, or I could leave them separate like this. So over here I said isolate those. Over here I can't because you're going to have multiples of them. So with this one option you may take is just to square it where it is. To get x, the square root of x minus 15 squared is going to be equal to the quantity 3 minus the square root of x squared. So when I do that, this whole thing just goes away and we get x minus 15 is equal to, when I'm over here, we're going to multiply this, so we end up with 9 minus 6 square root of x plus x. So actually here, the x's are going to cancel. We end up with, if I subtract the 9, we get a negative 24 is going to be equal to a negative 6 square root of x. Divide by negative 6. We end up with 4 will be equal to the square root of x. Square both sides. X is equal to 16. If I go back and check my solution with that, the square root of 16 minus 15 should be equal to 3 minus the square root of 16. We end up with, over here we end up with 1, should be equal to 3 minus 4. 1 is not equal to negative 1, so for this one in particular, we end up with that extraneous solution because one side does not equal the other side. So that's when you can identify, and that's why it's important to check your solutions so that you know you're getting correct solutions. Alright, let's take a look at what happens when we're using something that's not square root, but maybe a cube root. So with this one, and remember, when we have rational exponents, that means we're taking that root of something. So with this one, it's to the 1/3 power. So that means we are taking the cube root, the third root of that quantity. So again, let's isolate this, because there's only one root. So we'll have 3 cube root of 5n minus 1 is equal to 2. Added the 2 to both sides. Divide by 3, so we get the cube root of 5n minus 1 is equal to 2 over 3. And then instead of squaring both sides, we're going to cube both sides. So when I cube both sides, this, again, that just cancels this whole thing out, is going to be equal to 2 over 3 cubed 2 cubed is 8, 3 cubed is 27. So we end up with 5n minus 1 is equal to 8 over 27. When I add 1 over here, that means I have to add 27 over 27. So we get 5n is going to be equal to 35 over 27 multiplied by 1/5. That'll cancel here and make that a 7. So we end up with n being equal to 7 over 27. And when we check that, we would end up getting the correct answer. So that the answer is 7 over 27. Alright, the last thing we have to talk about, the last concept here we need to talk about, are radical inequalities. So this is one of our last definitions for this whole chapter. It's a radical inequality. And all that is, just like a radical equation, is just an inequality that contains a radical. So with this one, it is going to be a little bit different in our setup, because what we're going to do, we have to do actually a couple of different things here. We're going to set up those intervals like we had done before when using inequalities. The first thing we want to do is recognize what has to be true about the inside of our radical. It has to be greater than 0 or equal to. So the first thing I need to do is figure out what x values are going to allow me to be greater than 0 on the inside. I guess it's or equal to. If I add 4, 4x greater than or equal to 4, x is greater than or equal to 1. So whatever our answers end up being, we have to be greater than or equal to 1. So now let's go back to the original. We're going to solve this just like a normal equation. If I subtract the 2, we get the square root of 4x minus 4, less than or equal to 4. Square both sides. 4x minus 4, less than or equal to 16. And solve. Add 4. 4x less than or equal to 20. Divide by 4. X less than or equal to 5. So notice here I know x has to be greater than or equal to 1. Over there x has to be less than or equal to 5. So we're going to set up those intervals and test some of our solutions here. So we're going to test one lower than 1, because if we look at our number line here, we're setting up 1 and 5. So I'm going to test a value down here, let's say x equals 0. A value here, we'll say x equals 3. And then a value up here, let's say x equals 7. It doesn't matter what values you choose as long as they're in between there. Well, if I plug in 0, this can't happen because we end up with 0 square root of negative 4 and we get an imaginary number. So we already knew that can't happen. If we get 3, if I plug in a 3, 4 times 3 is 12, minus 4 is the square root of 8. 2 plus the square root of 8. Let's see, the square root of 8. Oops. Is 2.8. So 2 plus 2.8 is 4.8, which is less than 6, so this works in between here. Then if I try 7, 4 times 7 is 28, minus 4 is 24. The square root of 24 is going to be almost 5. It's going to be 4.9. 2 plus 4.9 is 6.9, which is greater than 6, so that does not work here. So then our interval would be anything, be 1 less than or equal to x less than or equal to 5. And that's just to double check what we did algebraically is correct. So we knew that ahead of time. We knew that x should be greater than 1. We knew x should be less than 5, but we wanted to guarantee that. So we went through and tested those intervals to make sure that what we got did satisfy that inequality, and it did. All right, the homework is 425, 11 through 27 odds. Our test for now, since you're watching this over the weekend, we're going to do the homework on Monday. We'll be reviewing, so the test won't be until later on next week. Probably Wednesday or Thursday of next week.